Hey folks, it's David with Streaming Relativity, home of the Astro DNA Observatory. So this is going to be a follow-up to my most recent video on capturing Jupiter with my used C11 XLT. And if you haven't seen that video yet, I encourage you to check it out. I briefly cover my workflow in Sharpcap and AstroSurface, and I think it's a decent primer for newcomers to planetary imaging. I'll leave a link in the description and a card in the outro of this video. And don't forget to subscribe. If you're into astronomy and all things astrophotography, you're going to absolutely love this channel. Now, those that did watch the video, you note that I mentioned a time-lapse sequence of Jupiter that I captured with Sharpcap. In fact, I captured about 36,000 frames over a 4-hour period while Io was transiting Jupiter. Here I'm showing 7 individual frames, each spaced by about 30 minutes. And as we follow Io, we get a sense of its orbital speed. It orbits at about 17.3 kilometers per second. And if we measure from frame 3, which is right before ingress, to frame 7, which is shortly before egress, Io takes about 2 hours to transit Jupiter. Now, these still images are awesome, but you know what's more awesome? Animation. Here's the result of 36,000 frames captured in 4 hours. I'm going to quickly share how I did it, and I think you'll find that it's relatively easy, but it is a lot of work. And the more time that you put into it, the better the results. If you're going to shoot a time lapse, it's probably a good idea to choose a time or a period that something interesting is happening with Jupiter. And I've pulled up the Sky and Telescope Jupiter's Moons utility, which I find to be pretty cool. And I've pulled up the date and time of my grab where I started my session. And you should, Io is just off to the left of Jupiter, and Ganymede is in the lower right. But what's really cool about this is that you can set your date and time. I'm in Eastern Standard, so I am 5 hours offset from Universal Time, which means that this is around 7:30. And you can see as I click 1 hour, 2 hours, see how Io is crossing Jupiter, 3 hours and 4 hours, and it's off to the right. So this is a great tool for you to be able to plan your time-lapse sequence. Okay, so I capture all my data with Sharpcap, and when you run the capture program, there will be a modal dialog, and in that modal dialog you can indicate your target name, and then you can specify details about your captures. And in my case, I use a time limit of about 30 seconds. So shooting at about 40 frames per second, that's going to give me on average 1,200 frames per capture. Now, you can also set a sequence. A sequence is performing captures in intervals, and the number of captures you do, in my case I did 48 captures, and the interval I chose was 5 minutes. So 48 frames of 30 seconds worth of capturing every 5 minutes is about 4 hours worth of data. Okay, so we go to our raw data from the 1st of December, and we see that we have stacks, which for me begin at 7:42, and they run until about 11:06. And what we're going to do is stack each of those, and we're going to stack them inside of AstroSurface. So we'll go ahead and open, starting with the first frame at 42, and we're going to go ahead and register with no rotation. Now, I've set up a parameter file so that the settings that I'm using here are automatically loaded, and those settings are we detect, first of all. We're going to perform an analyze, and I've decided to use 50% of the stack. going to say OK to this. I'm going to set my 48 alignment points, and I'm going to name this stack 1, and we're going to repeat this process of stacking each of the time-lapse points. So I'm not going to bore you guys with that repetitive task, but I'm going to stack frames for my time-lapse, all processed with the same alignment parameters. Okay, so now that I have a stack of each of these frames, I'm going to crop them. I'm going to crop them. There's an edit tool, geometry tool within AstroSurface that allows me to crop. I'm going to go for an HD, which is I think a 16:9 aspect ratio. I've taken the last frame in the time lapse because Jupiter drifted on me, and so the extreme limit of my field of view puts Jupiter down here, and so I've drawn a box 960 by 540 around Jupiter, which I think will allow me to track Io's transit, and you can see Io over here. And what I'm also doing is noting that the right hand side of the box is approximately 240 pixels off the edge of Jupiter, approximately. I'm also noting that the bottom of the box is approximately 90 pixels off the bottom of Jupiter. This is all approximate. This will allow me to perform this crop and have Jupiter roughly in the same position. I'll later use PIPP to do final alignment and stabilization of the frames in the video. And so we're going to give this a shot and see where it takes us. Okay, let me demonstrate the cropping procedure. First, we're going to open up our stacked frame. In this case, I'm going to open up 31. Note Jupiter is in the lower right of the frame, and that's what we want to kind of correct for by using the geometry crop. What I am doing for simplification is that I'm just choosing the edge of Jupiter as my starting point, and I'm lining up the edge of the bottom as my starting point. And roughly here, we'll just put it here for now. And obviously this is not the proper dimensions. This is 355 by 161, and we need to get to 960 by 540. But the first thing I want to do is handle the margins. We want a 240 pixel margin to the right of Jupiter. So I'm going to set this to 240, and what I'm going to do is actually increase. So now I have a 240 pixel margin off the edge of Jupiter. Now we also want a 90 margin on the bottom, so I am going to increase the bottom by 90. Okay, so we now have our margin set, 240 to the right, 90 to the bottom. Now the width that we are going for is 960. We're at 595 now, so that means we have a deficit of 365 pixels in the width. So why don't we adjust that by putting 365 as our adjustment, and let's let's add 365 in width by subtracting 365 from the position of the left border. So when we do this, we now have our 960 in width. Now height, we want to be at 540. We are 291 pixels away from that. So let's put 291 as our adjustment, and we want to do that by subtracting that from the current position of the top of the box. So let's subtract that. And somehow my math is not as good in my old age. We need to make it smaller, so we can do that by adding 2. So now we're at 965.40, and that looks to be about right. We know our margins are 240 and 90. We'll go ahead and we'll crop it. We've got it. Now we're going to save it out. After we say OK, we'll save it out. And we're going to save this to our cropped folder. And this stack is going to be 31. So as you can see, this is a bit tedious and perhaps even unnecessary, but it is the way that I'm approaching this problem at the moment. Okay, so I have my cropped images, and I've also set up a wavelet parameter file based on one of the images. I've already tested it on 2. Let's go ahead and test it on the 3rd stack. My workflow right now is I just do an auto white balance, and I set the black and white point, and I choose a little area outside to set the black point, and then I choose one of the bright clouds in Jupiter, set my white. Once I have that, I OK it, and then I go into my wavelets, and it's already applied. So you can save and apply parameter files. So I had saved this file, so all of my deconvolution settings, my noise pre-filter, wavelets, etc., and my RGB adjustments have been made and are saved to a file, so I can always load that file and it'll be applied. For now, I'm going to say OK to this. We're going to save this out, and I've been saving these out now as PNGs. So I'm going to run through this process and create all my PNG versions of the stack, and I actually will probably take these PNG files and do some further work with them in GIMP. I just feel a little more comfortable with GIMP for some of the fine-tuning that I'm going to need to do. So I'm going to save out a PNG for every one of my stacks. Okay, so I did the wavelet work in AstroSurface. A little bit of touch-up in GIMP on each of the, I don't know, I guess I have about 35 frames here using GIMP. You know, it's a mixed bag in terms of the images. Some of them are I think are good, and then we have some weird stuff going on here. It looks like the sequence may have been a little, I'm not quite sure what happened here, but I have an artifact that's flying with IO. But we're going to take a look at this, and we're going to go ahead and produce a video using PIPP. So PIPP is a tool that's in most planetary imagers tool bag. We're going to use it to create a planetary animation, which is essentially an AVI video file. And the first step is to load all of our processed stacks. Those are the PNG files that we just spent all the time creating. And we're going to confirm that the order of those PNG files is the order in which we want the animation to play. And we'll select planetary animation, and that's going to preset all the options in creating the video. And we're going to start with the processing options. So I'm going to use the default processing options, which include stabilization of the frames based on object planetary, and there's a slight histogram stretch that's going to be applied to each frame. Finally, I will set the crop size to 960 by 540 to make sure that our video is in the HD format. Next, we'll set the animation options, and I want the animation to go forward and then reverse with a 5-frame pause in between, and I want that to cycle 5 times. That will give me a decent length video. Okay, next I set the output options, and obviously it's an AVI file with MPEG-4 encoding. I started with a quality of 6, eventually I went to a 10, and my frame rate, it defaults to 10, but I think I ultimately set it to 6 frames per second, and I provided an output file name, and we were ready to do the processing. Processing was remarkably fast, taking a total of 2.8 seconds, and PIPP provided a nice little summary. Okay, so let's view the animation, and wow, I'm very satisfied with this video. Yeah, so some of the frames are a little rough, some blurry, but this is simply a function of the data quality as well as the time that I was willing to spend in creating this. And I spent a few hours. I easily could have spent a few days, and yes, I might have been able to get a little bit sharper, but for the purposes of this animation, I'm very, very happy. And you know, when I shared this with my family and friends, they were awestruck, and you know, the reaction to seeing something as amazing as the dynamics of a Jovian moon crossing the surface of our largest planet in our solar system, to be able to witness the bands, the dynamics of the bands of Jupiter. Most people don't get to see this. So this is an excellent tool for advocacy, and I just love the result. But it's much more than a amazing video. This is a treasure trove of celestial calculations here. We can calculate things like, obviously, how long does it take Io to transit Jupiter's disk. We can estimate the speed that it's moving at, given our knowledge of Jupiter. We can track how fast Jupiter itself is rotating by seeing the change in position of the various features over time. And how about that shadow, the shadow of Io? It's much more than some cosmic photobomb. It reveals how close Jupiter is to opposition. I shot this about 5 days before opposition, and so the shadow offset is telling us how closely aligned Jupiter and Earth are relative to the Sun. And you combine all this with what we do know about Jupiter, and we can even verify Kepler's laws of planetary motion. Who knew that a series of 5-minute intervals could unlock so many scientific secrets? And I just think this is fascinating. So get out there, do your time lapse, create your video, share with your friends. I think that it's just worth every ounce of time that you put into this. And with that, I am going to sign off, and I will see you all on the next video.